In today's lesson, we will be applying the three basic trigonometric ratios we learned about previously. Trigonometry is one of the most useful branches of mathematics. It's used in targeting by the military, in space exploration, yes, it really is rocket science, and in navigation, among other things. It can be used for indirect measurements of objects which cannot be physically measured. The basic applications of trigonometry involve two angles, the angle of elevation and the angle of depression. The definition of the angle of elevation is the angle formed between the line of horizontal sight and the line of sight to an object above the horizontal. In this diagram, we are looking at the worm's eye view. The worm can either look directly in front of us, or it can look up towards where the bird is. The angle between looking straight ahead for the worm and looking up is called the angle of elevation. The next angle is the angle of depression, and the angle of depression is the angle formed between the horizontal line of sight and the line of sight to an object below horizontal, or in this case, the bird's eye view. The bird can either look straight in front of it, horizontally, parallel to the ground, or it can look down towards the worm, in which case our angle, which we call theta, that's just a Greek letter, is the angle of depression. The cool thing about the angle of depression and the angle of elevation is this. If you take your angle of elevation and your angle of depression, you can see by the parallel lines that we have a set of alternate interior angles. You can see the Z here. So what we know is that our angle of depression is always going to be congruent to our angle of elevation. This can make your life easier when you're actually solving a problem. You can draw the triangle either way. Just be sure that you put the angle at the acute angle on the horizontal line. Now let's look at some examples. The first thing you want to do is you want to draw a diagram that represents a situation, identify your known and unknown values, and then identify which ratio you need to solve it. In this problem, it says J equals 50 degrees, so let's label it. It says little j is 12. Now, the typical method we use in mathematics for labeling our triangles is whatever the angle is, the opposite side is the lowercase of that letter. So 12 is opposite the 50-degree angle. R happens to be the right angle. We're interested in finding little r. So let's look at the relationships we have. We have an angle, which is 50 degrees. We have J, which is 12, which is our opposite side. And we are looking for r, which we don't know, and that is our hypotenuse. So looking at the information we have opposite and hypotenuse that we're working with. So out of SOHCAHTOA, we are going to pick sine because that is the one that involves opposite and hypotenuse. So here's what I know. I know the sine of 50 degrees equals 12 over r. Now, I need to solve that equation for r, so the first thing I need to do is I need to get it out of the denominator, that fraction. So I multiply both sides by r. On the right side it cancels. On the left side I now have r times the sine of 50. So this is my current problem. R times the sine of 50 degrees equals 12. I want r alone, so to do that I'm going to divide both sides by the sine of 50 degrees. This is now a calculator problem, so we pull out our calculator, and again we always check our mode to be sure we're in degree mode. We are. So I'm going to quit that screen and I'm just going to type in 12 divided by the sine of 50 degrees and enter, and it tells me our answer is about 15.7. So let's go back and put that into our problem. R is about 15.7 units. Now, let's take it to an actual application. We have a chair at a ski lift, and at the resort, it rises at an angle of 20.75 degrees, and it attains a vertical height of 1,200 feet. So you can barely see the little ski chairs going up the hill here. The angle is 20.75 degrees, so here's my angle. The vertical height, that's vertical going up, is 1,200 feet. And now I have some questions to answer about it. The first one says, how far does the chairlift go up the side of the mountain? So I need to see where the chairlift is going. It's not going across the bottom, it's going up the side. So on that particular problem, I'm actually looking for C, or the hypotenuse of this triangle. 1,200 is opposite, so I'm dealing with opposite and hypotenuse, which means, again, I'm going to be dealing with sine. So I know the sine of 20.75 degrees equals the opposite side, which was 1,200, over the hypotenuse, which we called C. Go ahead and solve the problem and then check your answer against the podcast. I hope you got C to be about 3,387 feet. Now let's look at the second situation. The helicopter crew is overhead and it's viewing the skiers' downhill run, and the question is, if the helicopter flies a horizontal path, level, what is the length of the path of the helicopter? So my helicopter is actually up here, and it's going this way following the skier down. And the key to this again is that it's the same angle of elevation depression. It's the same thing because of the alternate interior angles. 1,200 feet is still the vertical side, so I'm interested in the path across the top, which is going to be the same as the bottom side of the triangle that I already have gone. So now I'm interested in side B down here. So let's go ahead and set that up. B happens to be adjacent to the angle, and the side that I already know exactly is 1,200 feet, which is opposite. So on this problem, I'm working with opposite and adjacent. Be sure you go back to SOHCAHTOA to figure out which function you're going to use. And I see opposite and adjacent is tangent. So I'm going to set my problem up as the tangent of 20.75 degrees equals the opposite side, which is still 1,200, over the adjacent side, which I'm now calling B. Go ahead and solve the problem and then check your answer against the podcast. Hopefully you ended up with a final answer of approximately 3,167 feet. Let's look at two more examples. In this example, we have a person at the circus in the audience is at ground level, and he is watching the high wire routine. The acrobat is 5 feet 6 inches tall. He's standing on a platform that's 25 feet off the ground. And the question is, how far is the audience member from the base of the platform if the angle of elevation from the audience member's line of sight to the top of the acrobat is 27 degrees? So we're going to start by drawing a picture, finding the right triangle and labeling it, and then determining which trigonometric function we should need. So the first thing I'm going to draw is a high wire. So it has a wire across the top, and it's got two poles at each end to hold it up. There is a platform on it, and there is an acrobat on top. Now, what I know so far is I know that the high wire is actually 25 feet off the ground, and I know that the acrobat is 5 feet 6 inches. Well, 5 feet 6 inches is 5.5 feet, so that's 5.5 feet off the ground. I know that I have an audience member out here, and he's looking up at the acrobat. And the question is, how far is he away from the base of the platform? So let's take a look at it. Can you see the right triangle we have here? Be very careful with the right triangle. The opposite side is not 25 feet. The opposite side is actually 30.5 feet because it's from the base of the platform all the way up to the top of the acrobat. Now, it also told us that his line of sight was 27 degrees. So that meant his angle of elevation was 27 degrees. And then we need to be very careful about the question. It said, how far is the audience member from the base of the platform? It did not say how far is the audience member from the top of the acrobat. So our question is this side over here, which would be X. So we look at our problem and we have to decide which pieces we have. I have an angle, which is 27 degrees. I have 30.5 feet. Now I need to know, is that opposite, adjacent, or hypotenuse? And since it is across from the 27 degree angle, that means it's the opposite side. And then the answer I'm looking for is X, which is the adjacent side. So the function for opposite and adjacent out of SOHCAHTOA is, once again, tangent. So we're just going to use the tangent. Go ahead and set up your problem, solve it, and then check your solution. Hopefully your work checks out and the base of the platform is approximately 60 feet from the member of the audience. Now, in our next problem, it's actually the trickiest problem of the day. It says we have Olivia in a lighthouse on a cliff, and she is observing two sailboats that are due east of the lighthouse. The angles of depression to the two boats are 33 degrees and 57 degrees, and our question is to find the distance between the sailboats to the nearest foot. So let's take a look at that. We have a lighthouse sitting up on the top of a cliff, and part of the information that you don't have is that the distance from the sea to the top of the lighthouse is about 185 feet. Now, we also have two sailboats out here in the water, and the angle to one of them is 57 degrees and the angle to the other is 33 degrees. So basically what we have is we have two triangles formed here. One of them has a 57 degree angle, the other has a 33 degree angle. So we're going to look at these. Let's go ahead and finish drawing the triangle. I like to draw my triangles with the horizontal side at the bottom. So the 57 degree angle is when you're looking up even higher, so you would have to look up higher the closer you get. So our 57 degree angle is on the closest boat, and our 33 degree angle is on the farther boat. We have two triangles formed here. One of my triangles is 185 and 57 degrees. The other triangle is 185 feet and 33 degrees. What I'm really interested in is this distance between the two boats, just this little piece here. Well, if I can find the distance to the 33 degree boat, which I'm going to put in green, and the distance to the 57 degree boat, which I'm going to put in black, if we can find both of those different distances, the difference between them is what we're looking for. So I'm going to set up my proportions for each of these two triangles and get those distances and then subtract them. Go ahead and do the work and then check your answer. After working with the first triangle, the black distance was approximately 120 feet. Continuing with the green triangle, I came up with that distance was approximately 285 feet. My actual answer is going to be the difference between them, so I'm simply going to subtract. After subtracting, I came up with 165 feet, so the distance between the sailboats is approximately 165 feet. This concludes today's podcast.